Hey, good morning, everybody. My name is Scott Alchevic. Thank you for joining us for this webinar on electronic engineering technician, precision machining, and sheet metal systems. I'm with the NSCC recruitment team, and just going to give a few seconds here. I see some people coming in now. So this is kind of a program spotlight. I have a couple faculty members from some of our campuses with us this morning. We've got Brett Sampson from King's Tech campus. How you doing, Brett?
Good, how are you?
Good, good. Thanks for joining us. So Brett's going to talk about electronic engineering technician in a couple seconds. And we've got Willie DeBay from Akerley campus with sheet metal systems. Hi, Willie.
Hey, how you doing? Nice to see you, Scott. Proud to be here.
All right. Thanks for joining. And we had another faculty member, Kimball Edwards from Pictou campus, to talk about precision machining. There may be some technical difficulties on his end joining, so if we get to that portion of the slideshow, I might just skip over that and get to sheet metal systems and wait for him to join. And if for some reason he can't join, we'll go over some of the details that I have for the program. So I'm just going to switch over to my PowerPoint here. Just want to start off just by acknowledging the land that we're on. NSCC acknowledges that we are in Mi'kma'ki, the unceded territory and ancestral homeland of the Mi'kmaq Nation. Our relationship is based on a series of peace and friendship treaties between the Mi'kmaq Nation and the Crown dating back to 1725. In Nova Scotia, we recognize that we're all treaty people. So for anybody out there who's not familiar with Nova Scotia, if you do come to NSCC, there are quite a few Mi'kmaq communities in the province, and I encourage you to check those out and learn about the culture. Lots of faculty, staff, and students at NSCC from the Mi'kmaq communities as well. During this presentation, there is a questions pane that I will keep an eye on. You can pop some questions in there if you want, and just know that if you're going to ask questions about your application or personal information, we probably won't be able to address those here on the webinar. It is being recorded, and you can send those questions to recruitment@nscc.ca. But if you do have questions about the program, you know, things like maybe what's a typical schedule look like, or anything sort of looking for insight on the programs that we're talking about, by all means, put them in there. And some general application questions are also welcome too. I can answer those, but I'll just keep an eye on those, and we'll get to those throughout the presentation or save them for the end. So, like I said, this is a program spotlight. We are focusing on 3 particular programs this morning. As I mentioned, Brett Sampson teaches electronics engineering technician program at King's Tech campus, which is, I don't know if you can see my mouse moving, but King's Tech is here in an area we call the Annapolis Valley, which is about an hour and a bit outside of Halifax. And then Willie is down in Akerley campus, which is in the HRM region. So that's Halifax and Dartmouth area. Akerley is quite a large campus. We have a lot of trade programs there, culinary, tourism, and other programs there as well. And then Kimball teaches up at the Pictou campus. The precision machining program is there. We also have precision machining at King's Tech, and we also have electronics engineering technician at Pictou. So there's some of our programs are offered at multiple campuses. Sheet metal systems, the only campus for that is the Akerley campus. So you can learn more about our campuses if you go to nscc.ca/explore NSCC. There's a link there to learn about each particular campus and a bunch of other stuff about NSCC. So I'm going to hand this over to Brett just to talk about his program, Electronic Engineering Technician. Over to you, Brett.
Awesome. Thanks for having me. The Electronic Engineering Technician program offered at King's Tech. It's really practical to learn how to install, troubleshoot, and test the repair the next generation of electrical and electronic systems. In industrial electronics, which is what I worked in, you'll learn motor control, machine logic with programmable logic controllers. So these things control how machinery works. They're pretty fun to play around with. You work with HMIs, which are touch screens used to interface with machines. So you can program touch screens that'll control machinery, which are being used quite a bit more often nowadays. More and more robotics are being implemented in plants, so you'll have plenty of opportunity to learn about them. The plant I was working in, which was the Michelin plant in Waterville, they just installed like 10 different robotics machines, which are pretty interesting. So on the job, there's a bunch of different kind of fields for it, but my field, you were usually come into work, you wait for a machine breakdown, and then you go out and try to solve the puzzle on what's the problem with the machine. You'll be sifting through electrical prints, programming just to find the root cause of the problem. So it's really challenging, and I find it's pretty fun. There's always opportunities to learn new skills because technology is advancing at such an accelerated rate that the job never gets boring. So if you have any off time, you can learn about all this new technology. And the NSCC program keeps up to date with all the new technology pretty well. There's a lot of.
Can I ask you just a quick question? What would be the difference between a technician and a technologist? I know we have the different programs. Yeah.
Yeah. So I didn't see much of a difference at Michelin because they trained you to do both. But technologists are mostly for design. So if you're designing, let's say, PLC systems or circuits, you'd be more of a technologist, and they are geared towards more higher end math. So you'd be doing calculus and stuff, whereas a technician is more so repair and troubleshooting. And most of the math courses you do in the technician program pertain to the general theory of general electrical theory that you take. So it's a lot less advanced math. It's a little bit more on the checking components and troubleshooting as opposed to design. But we don't have the technologist program at King's Tech. I think that's in Ivany.
Yeah, I think so.
Yeah.
Well, you mentioned courses, so I think I'll go to the program map here. So this is basically, this is a 2-year program for anybody wondering. It's a diploma program. So we have sort of semester 1 and 2 and 3 for year 1. And maybe Brett, if you just want to, take us on a tour of these courses and kind of what they're all about.
Yeah, so TechComms really helps you with like building resumes, how to do up work procedures, a lot of non-technical related stuff that you'd be doing on the job, which is really helpful because I never really had a course helping me write resumes, so it's really, really practical. DC circuits is basic electrical theory, so they'll take you through how electrons move at an atomic level and teach you the fundamentals of electricity. Digital logic, it's mostly kind of little puzzles with integrated circuits. You have AND gates and OR gates that help you make up electronic logic. Electronic fabrication and soldering is you learn how to solder and repair printed circuit boards. It's pretty fun and it's pretty practical too. Applied math, like I was saying before with the technician program, it's actually applied to the DC circuits class and the digital logic class. So you get extra practice for both of those courses. WIMIS, which is a where I was working anyways, it was a yearly course that you had to take to keep up to date. It's kind of an introductory course to WIMIS, and the Occupational Health and Safety Act is very similar as well. Electronic drafting, you learn how to use AutoCAD, how to print read, how to make up professional block diagrams and stuff. And we do a little bit of troubleshooting in that as well using the prints that we make up. AC circuits is the second portion of DC circuits. So you work with alternating current, which is the kind of electrical signal that goes to your house. Digital Logic 2 is just expanding on Digital Logic 1. introduction to computer hardware and networking devices. You learn how to build a computer from scratch. You learn how to troubleshoot components. Networking, you learn how Ethernet works, how serial communication works. It's pretty fun stuff. And since in the industry, it's getting a lot more computer based, so it's a lot more practical nowadays too. Semiconductor circuits, there's 3 courses for that, and they basically touch on all the different type of semiconductor devices that you'll find in components in your house and in industry. So you learn the theory and the practical applications of all of those. Applied math is just a second version of the Applied Math 1, and it pertains to AC circuits and digital logic 2. Semiconductors 2 is just an expansion on 1. And cooperative education, I think that might be work term.
Yeah. So I'll just jump in here and let people know that, semester 1 at NSCC is typically from September to December.
Yeah.
Then there's a break for our Christmas holidays, and then semester 2 begins January and runs until the end. Well, right about now, actually today is the end of term, isn't it?
Yeah.
So, that's semester 2, and then semester 3 or spring session begins. And I see that you teach a course during that semester, but then people also have the option to go off and do their work placement or their co-op. Mm-hmm. So I think in your particular course, there's a mandatory 5 to 6 week work placement, or students have the option to sign, like when they apply to do the 15, 16 week co-op placement. Does that sound right?
I'm not sure about the co-op. I know they are mandatory to take semiconductors too. Mm-hmm. Work experience in second year is mandatory.
Oh, okay, second year. Yeah. I see. Yeah. So,
do you want me to continue with year 2?
Yeah, that's kind of a tour of year 1. So, as everybody can see, the first semester and second semester are there's a lot of stuff to learn there. These are all the fundamentals to the program. What would a typical week look like at King's Tech in this program, Brett?
So this semester I can find a schedule, or I can just kind of.
It's a full-time program, so typically it's Monday to Friday.
You'll probably have 3 to 4 classes per day. Friday's usually about 2 classes. Mm-hmm. This semester, the Friday is pretty laid back, so they have 2 hours of drafting, and then they have 1 hour of AC circuits, and that's it for Friday. Most of the time, you try to get most of the courses done by Thursday. It's not super technically heavy because electronic drafting is a little bit easier going, as is introduction to computer hardware and network devices.
Yeah.
And the applied math actually pertains to AC circuits and digital logic 2, so it's kind of like an extra course that helps you on those 2 courses.
Right.
So it is a full-time course, and there is some practical courses in there to help kind of gain your interest and give you a rest from the harder theory courses, but it is you'll learn a lot. And
I won't ask you to go over year 2. I will say if anybody has any particular questions, you can email me. I can send you this program map. I can probably connect you with Brett at King's Tech if you have specific questions. One of the questions we get a lot is people who have previous training. We do have a process for recognizing prior learning. The process is you get admitted into the program first, and then you can work with your advisor on transferring credits in, things like that. So if you say you were in the armed forces or something and you learn some of these topics already, maybe there's some things that you can transfer in, or if you've come from other parts of the industry. So I'm just gonna go to the next slide here, and just Brett, if you don't mind, I'll just let people know the admission requirements for this program are pretty straightforward. You do have to have your high school, but you also need to have that academic grade 12 math. as you heard from Brett, there are some technical math courses in the program. So having that academic grade 12 math background is required in order to be successful in that program. Keep in mind, when you get to campus, there are supports and resources there if you need extra help for your math, but you do have to have that academic grade 12. If you don't have it and you really want to take this program, we do have another program called Academic and Career Connections where you can obtain that course that's required for this. So you can get that course and then apply for this electronics engineering technician program. And there is like every one of our programs has a program page where you can look at tuition and things like that. See where this is going to open. I'll have to drag this here. So I'm just going to quickly take you guys on a very quick tour of a program page. So this, you can find every page, Willie's program and Kimball's program all have pages like this that talk about the program. They give you an overview. So here's some information on work experience. We talk a little bit about locations and availability. So Brett's at Kings Tech campus, but this program is also offered at 3 other campuses across the province. We've just looked at those admission requirements. Then there's your tuition tab, which gives you an idea of the cost for domestic and international students. And then you can even go further and look at some costs and estimates for things that you need for the program by year. And then there's a career and future study tab, and then kind of a tab that goes over some of the first year courses that Brett was talking about. So if you're curious about learning more about that program and the costs and things like that, the program page would be a great place to go. And then of course, if you have additional questions, you can email recruitment at NSCC, and we certainly can connect you with student advisors at Kings Tech or faculty in the program. I'm just going to go back to the PowerPoint, and Brett, if you can, in maybe like 2 or 3 minutes, if you can just kind of cover some of these main points, just like how you mentioned Michelin. I'm sure that's industry that we're connected to at Kings Tech, so students get that practical experience there and other places. But what are some other places that students will go and do their work placement?
So I know quite a few students are going to be working at Geospectrum, which is a sonar-based company in Dartmouth, and they work a lot with integrated circuits and sensors and stuff. I was recently talking to a second-year student that worked there first year, and he said it was really fun. You learn a lot more in soldering. You pretty much sit in the lab and tinker around with electronic circuits, testing sensors, stuff like that. It's pretty fun stuff. A lot of factories also have industrial electronic jobs where you can either repair broken parts at a component level or troubleshoot machinery at like a block level. I think there's a pharmaceutical company in Windsor that also employs electronic technicians, where you would be repairing machinery and stuff like that. Students learn in hands-on in industry settings. So yeah, that's one big thing I was talking about with work terms. You'll learn in the industry and you'll see the practical applications of what you'll be doing. I find it's really helpful to get more into the program once you see what your end goal is. So there's a lot of opportunity for that. And we try to keep in touch with people from industry so we can keep up to date with the technology and also be relevant with their different skills they're looking for and stuff like that. But the job ready skills, usually you'll pick an avenue that's your strength and go with it. So Michelin would be more programming and troubleshooting PLCs, whereas Geospectrum would be semiconductors and soldering and stuff. So if you're good at one, you can go in that avenue and build a career in it.
Awesome. And that last point there on labor market information, there is a really neat website, explorecareers.novascotia.ca, that the province has put together. If you go in there and search electrical and electronics engineering technologists and technicians, you can get some sort of an overview of the market in Nova Scotia. You can get information on like medium and or sort of low and high salary ranges, who's hiring. Like there's all kinds of interesting information there on this. So yeah, I think Brett, I think that's a kind of a pretty good look at the program. We looked at the first year courses, kind of where people can do their work experience. You'd mentioned automation and robotics, and of course we all know that's just getting more and more in all sectors of the economy. So I would I'd say the jobs in this field are just increasing.
Yep, and there's also jobs for renewable energy too, so like solar panels and stuff. Yeah, it's the job sector is actually growing quite a bit for electronics, which is pretty good.
Yeah,
pretty good stuff.
That's great. Thanks so much. So there is one quick question here. Are the programs the same at each campus? So is the curriculum the same for the program?
They should be, as long as you remain in the technician field. You might have a different elective. So I know Ivany, they have a bunch of different electives that they offer, and you can choose one because of the amount of students there. But in King's Tech, there's obviously not as big of a population, so we pick an elective that we think is kind of relevant to the job field, and then you'll go into that. So if you take it at Marconi, they might have a different elective picked.
Right on. Thanks, Brett.
Yep, thank you.
I'm going to there are a couple questions coming up here, so I'm going to hand it over to Kimball, who joined us just a little bit ago. Hi, Kimball, how you doing?
I'm doing pretty good. Can everybody hear me?
Yeah, can hear you fine. So just like Brett did, I have got these few slides here. We'll give you 15 minutes or so to talk about your program. I can, and when you want me to advance the slide, the next one is a program map showing the kinds of courses that students take. But so you're at Pictou campus. Why don't you introduce us to precision machining at Pictou campus?
Well, I think, are we talking the one-year program? Because it's been changed now.
Yeah. Yeah.
So one-year precision machining. So the basic format for us is taking a student from the beginning and teaching them all the necessary skills that they would need to produce pretty much anything that can be produced. And when I say that, anything out of steels and plastics and forming aluminums, pipe, metal. Just an example, we all made V blocks there just recently, so the students would make the clamping system and then going by different drawings, make the V block. And these are a tool that's used commonly for doing layout work and that kind of thing. The basic idea for us is to take the material from the very start, coming from the production mills, so round stock, square stock, and so on, and using equipment like milling machines, lathes, saws, drill presses, and so on to develop parts that are needed for mostly mechanical aspects of things like, for instance, parts for heavy equipment right down to automotive and motorcycles, those types of things. So gears and clutches and not all that. Anything that's basically produced, it begins with learning the basic machining, which is your standard one-year machine shop program. So ours is going to be a 1+1 program, which means after you're done your first year, you will come out with a certificate, and the certificate allows you to go immediately to work at a manual machine shop, or you can continue on with the +1 and do the CNC machining, which will be offered, I do believe, in Halifax at some point, and King's Tech. So you can take the one-year program here or the one-year program at King's Tech and then move forward to go to Halifax or remain at King's Tech to take the second portion of that.
Right.
And
Okay.
an advancement.
Yeah. So Yeah, because machining used to be a 2-year diploma program, so I'm assuming the first year was the hand-controlled precision part, and then the second year would have been more of the CNC type of stuff. So we've kind of split that into 2 1-year programs now.
Yes, that's correct. You
Okay.
can still take both programs, but you would have to start with the precision machining, which is your program, yes. So if you want to advance to the next portion, then I'll go over the different courses that are. So we have the standard communication stuff, as does everybody, which would have to do with memos and, you know, just your standard stuff, job orders, that kind of thing that you would see in any shop. The general safety, I think everybody would take general safety. We're very big on safety machine shop because all the gear is big, heavy, and dangerous. Basically, it's the same as doing any type of heavy equipment work where you don't want to get, you know, work unsafely. There can be some drastic problems if that's the case. Then we go to the basic sawing and grinding operations. So learning to use like hand hacksaws and files and grinders and band saws and cutoff saws and that type of thing. And we have a couple projects. Actually, the clamping system here was done on a band saw with some hand grinding, hand filing, and it was done to a drawing. So basically the shape itself had to be done on the bandsaw. And then there was some drilling and tapping, which is getting on to the hand tools. So the next portion would be drilling operations. So we did the drill blocks kind of thing. Some of them are just standard. What we try to do is make tools that the student can carry in their toolbox and use further on down the program. So after the drilling, we go to the turning operations 1. So in turning operations, you use a lathe, like a standard lathe, sort of like a wood lathe, a lot heavier, bigger, and they will basically be used to spin anything that is cylindrical. So you can start with a piece of raw material and then cut it down to a specific shape. So every student makes a little hammer. So this is just a piece of aluminum that would have came as just a shaft of aluminum raw material. They put it in the lathe, spin it, and using cutting tools like high-speed steel and carbide, types of sharp blades, they come along and they would learn how to manipulate the machine to cut any shape that they wanted. All right, and so that covers just about everything in the cylindrical market, which is a lot of products. If you go on from there, after the turning, it mentions the engineering drawings. Well, everything that we make, all of these parts, need a blueprint. And that's your engineering drawing. So we start at the very basics of engineering drawings. What shape, what types of line, what's the outer lines, what's a dotted line, what do the arrows mean, and so on, and just basically teach how to create and read engineering drawings. From there, it goes to the mathematics. Doesn't matter what trade you take, you're gonna have math. Math is normal life. Everything adds and subtracts. So we have mathematics that are based around the machining or the trades, and this mathematics complements what we need to do in our project. So basically, as we go along, the math will be taught to you that is relevant to the projects that we're doing at the time. And then introduction to hand tools, that covers everything from simple wrenches and screwdrivers right up to just about any type of hand tool that you might use in a mechanical operation. Of course, down below that, can I click that myself? Yeah.
Oh,
Yeah. Oh, up a bit there. Yeah. So then we have, of course, safety. WMIS and OH&S, same thing. If you're in a mechanical trade, WMIS, OH&S, safety, that's going to be included in all of them. Engineering drawings too gets more to the advanced engineering drawing stuff where you're looking at the different concepts of engineering drawings and how we read them as a machining trade. Then you go to more mathematics to complement the math part of it. I missed the introduction to precision measuring tools. One thing about the machine shop is that our measurements are not down to 1/8 of an inch or 1/4 inch. We're talking down to thousandths of an inch. So the basic idea, and we even go tighter than that, but for the first year machining, your final projects would be precision that is about 1/1000th of an inch. plus minus. So basically, if you pull a hair off your head and split it 5 times, that will measure about 1/1000th of an inch. So the tolerances for these machines is really accurate. And that's because if you put 2 parts in a machine together, they have to work together. So if you go by the drawing, you make the tolerances that are given, the parts that you are making should fit on a machine that might be in another town, county, or even country. So the precision of these things has to be very specific. So we work to learn these types of tools that will allow you to measure with that precision. Micrometers, vernier calipers, universal protractors, those types of things that are very accurate in the measurement. Then we go to our milling operations. So anything square. So in the lathe operations, we did round parts. Mills will do XYZ axis cutting. This is just a simple little tool that we get the students to make. This holds another tool that sits in the lathe so that it will cut. So we just make this by setting it in a vise on a milling machine and learning how to do all the different styles of cuts and angles, some drilling and tapping and so on, just to get them used to the work on the milling machines. So that's for anything that is not cylindrical, usually the square or flat parts of the, or even bolt hole circles or gears. And then it goes to threading operations. Every part, I don't know if I get this apart, everything that we make as a fastener style of some type. If you're working on a car, if you're working on anything, most fasteners are threads. So in many cases, they can't be produced in mass because they're not needed in mass. And therefore, when you come to the machine shop, we produce them ourselves. This is a cap for this particular hammer. And that was produced on the machine by one of the students. And he cut the threads with a tool and made the part that would fit into the hammer. So he can place things inside and have them locked in, secured by this fastener. Right? So that is covered under threading. We learn to do internal and external threads on special parts. So if somebody breaks a, I don't know, a Russian tractor that has large threaded areas that, for instance, can't be bought, then we would teach how to repair that in this milling operations and threading. So then the turning operations too just gets to be more advanced. We learn how to do more precise things, do fine tapers and so on, things that would be more precise for instance, doing pins and bushings that involve bearings. Very tight tolerances because they have to press on precisely. It can't be oversized, the bearing won't function properly. So it's just more advanced stuff that you would do. The work experience in co-op, we do have a work experience that's 5 weeks. The co-op, you can sign up for the co-op and pay a certain amount of money. And I think that's a 15-week co-op where the government steps in and pays 1/2 of the wages of the employer. So if you start at the beginning, we had one student try that, but he tried too late. But if you start at the beginning and sign up for co-op and you can find an employer willing to do it, then you would get 15 weeks of paid work rather than doing the work time. For the rest of
We
it.
won't, that's great, Kimball. I guess the program map I'm showing is showing both years, but like you say, precision machining is just, we're just talking about year 1 in this case.
Exactly.
So I guess the CNC part would be the year 2 from this map. So
Yeah, that's what we're currently teaching, yes.
okay, excellent. So yeah, I mean, obviously, I'm just gonna zoom back out here. Almost everything that we touch and use every day has some kind of part in it that's probably been machined by a machinist, either by computer or by hand. So I'd say, just gonna go to the next slide here. I'll get back to you, Kimball, on sort of like where our graduates find themselves and those kinds of things. But just quickly, the admission requirements for this program is just a high school diploma. Like Kimball said, there is math involved in almost every trade, but there are courses in this particular program that will teach you the math that you need to know for precision machining. If I click this, bring this page back over here. Again, here's the precision machining program page. Has all the same layout as the last one. Just let me maximize this. And again, you can see the, oh, what's happening here? Stop responding. Yeah, so Kimball's at Pictou, but that program's also offered at King's Tech where Brett is. The admission requirements we looked at. Tuition is the same, $36.20 for domestic students. That's Nova Scotian and Canadians. And then international students pay the $11,690. And then there's other costs and fees that you can look at. So for careers and future study, there's some options there. This is a trade that's you can become certified in through the Nova Scotia Apprenticeship Agency. So maybe Kimball, just a few words on that. How many hours towards certification do you get in the program?
When we take the 1-year program, I think they're going to have about 1,000 hours. The whole program itself, to go through the apprenticeship, I think you need 5,000 in the end. I can't change it around a bit, but basically 4 years is what you end up. Right now, the demand for machinists is through the roof. Like literally, I haven't got one guy that made it out of the county to go work. They've been scooped up locally in this town, Trenton, Linesbrook, New Glasgow area. Nobody has gone outside of the county, and Halifax is crying for them. I know right now that some of the largest machine shops are taking people in from overseas. Actually, quite a few Ukrainians. They've been kind of taking some Ukrainians in, some other people from different countries, because they just can't find machinists. You know, it's the mechanical, kind of the production of everything, because you touch, even if, like, for instance, this simple remote, all that plastic was made through basically plastic mold injection of some type, which is done through CNC machines, which is the add-on to the machining. So those who do the CNC and use the CNCs and CAD CAM systems to do the molds that make these plastics for your water bottles, everything. There's a ton. It's the biggest trade in the world, and it's the best hidden trade, because you don't see a machinist out on a roof pounding nails, and you don't see him coming into your house to fix the bathroom. It's a hidden trade, and that's the issue. A lot of people don't understand what it is. So
yeah, that's great.
Yeah.
And of course, every tool that we hold, and like I say, I'm just looking around my apartment, and pretty much everything I'm looking at, a machinist is probably involved with.
Yep.
Whether it's the casing for something or stuff that's inside the device. So I just wanted to, again, recommend people check out explorecareers.novascotia.ca. If you do search machinists and machining and tooling inspectors, you'll get some information on that, market information on that particular occupation. And if you have more questions about this, feel free to get in contact with us, and we can put you in touch with Kimball or other faculty at King's Tech campus. And yeah, thanks so much, Kimball, and thanks for showing those examples as well. That was great. Brett, I know you've done your part. There is one quick question here, and then if you do have to go, that's totally okay. But the one question from earlier was, what kind of courses can students choose as an elective in your program? Oh,
You're muted.
yeah.
All right, so yeah, if you went to Ivany, you'd have a choice between a bunch of different ones. I'm just going to get them up right here.
While you're doing that, I'm going to make you presenter now, Willie, because you're coming up next. So.
Yeah, there's a lot of them, so that's why I gotta look them up. Let's see. All right, so there is wireless communications, advanced programmable logic controllers, Android application development, automated test equipment, capstone project, which is what we do at our campus, computers and networks, electronics for smart grid, electronics for renewable energy, introduction to renewable energies, introduction to robotics, rapid prototyping, residential electronics, RF interference, and that is it.
Awesome. Thank you so much for that. Yeah, there was one member in the audience was just wondering about that. So again, and if you need that list again, just email us at recruitment and we can get you in touch with Brett. So.
Yep.
All right, Willie. So we're talking about sheet metal systems next. And I'll hand it over to you, Willie. I think everybody can see, I can see your PowerPoint. Can you, Kimball and Brett, see it? Okay, so I think our audience is good there.
So everybody can see that, can they?
Yep.
Okay, Brett, I wanted to apologize to you, bud. I made a little noise there while you were doing your presentation, so I wanted to apologize for that. Sorry about that.
That's
The
okay.
first thing that I wanted to mention to you is that I'm the instructor at Eagley campus for sheet metal systems, and I'd actually like them to add ventilation systems because that's basically what we do. Almost 90% or 95% of the buildings that you would go into, they're going to have some kind of ventilation system, and that's basically what we do. Okay, so that's what I'm trying to convey to you today. And let's say, what is sheet metal? Sheet metal is kind of broken into two categories. We have the basically installation side, and then we have the fabrication side. So the fabrication side, basically you make all the materials that you install. Okay, so unlike a lot of other trades, we don't go to the manufacturer and buy everything that we install. We actually make a lot of the components that we install. Okay. Oh, sorry, you shouldn't be getting that. Okay. This is just a couple little projects that I wanted you to see. This is a basic installation that you might see, and it doesn't look very neat, this one right here. It's just some pictures that I had. Okay, this is a little bit more fancy. So this is a little bit of copper, just showing you some of the different metals, materials that we used. We got the galvanized there, guys. I can't get this to stop. I'm sorry, because I can't get the full screen on it. So did you guys lose that?
No, I still see installation portion of sheet metal.
Unfortunately, my volume is going. Can you guys hear that in the background? No.
No.
Okay, sorry. Anyway, I want to show you some of the things they actually do in the sheet metal trade, and I want to go through the program. So the main programs that we do our safety and rigging. That'd be the first thing you start with. The second thing that you start with is your tools and equipment. Can you guys hear that?
No audio, no.
Okay. Okay. So we got our tools and equipment. I'm sorry for the interruption there. Tools and equipment. We got our power tools and equipment. Going through here. This keeps moving. I'm really sorry. I thought this was going to be helpful, and basically just going through the slides on its own, and I can't stop it right now because of where I am. Anyway, we're going to do fabrication fundamentals. With that, what you will do is you will actually do pattern development to start with. When I say pattern development, that is basically drafting. So you'll draft all your fittings that we do in the trade. And once you're done the drafting, you'll do about 3 or 4 of those on paper. And then usually in the afternoon, what we'll do is we'll actually fabricate those fittings. So whatever fitting you did in the morning, we'll actually make it out of metal, which is really nice. Okay. Blueprint reading and sketching. Most of the jobs that we install, you have a blueprint that you actually have to follow, and then you install your stuff according to whatever the blueprints say. Okay. The big thing with the blueprints is you'll have to learn the symbols, what they mean, the different types of plans, where to find things. We'll go through all that. And you'll learn how to do the sketch of the drawings that we'll actually install in the job. Okay. Our safety and rigging, that'll be the first thing. I already went through that. Tools and equipment, these are the basic tools that you'd actually see on the job. Okay, so in the shop, when we're making these, we have hand tools that we work with. This will give you the basic hand tools that you'll work with. These hand tools, you'll learn how to use them safely and effectively, and you'll use them what application you should use them on. All right. Next thing is the power tools and equipment. Like any trade, we use power tools and equipment. This will be in the second semester. Okay. And the idea is you'll be using these power tools almost every day in the trade. So you'll learn how to use those effectively in the trade as well. Our pattern development and layout, like I said, that'll be drafting that you do. These are a couple drawings that we're showing. There's basically 4 different types of layout that we will learn. The first being simple layout. You'll do parallel line development, you'll do radial line development, and you'll do triangulation. And with these type of layouts, you can basically make almost any of the fittings that you'd need to make, okay? Like I said, with the fabrication fundamentals, you will actually, these are some drawings of the fittings that we do when you're doing this project. And these projects are the basic fittings that we usually use every day out in the field. You'll learn how to make those, and you will make them out of the metal. Most of the materials that we use for this type of layout will be galvanized, and we will probably be using a lighter gauge just because you're starting and it's a little bit cheaper to make these products. So with the blueprint reading, I kind of already mentioned that a little bit. I want to go through it, but basically what it's showing you is the plans that you'd see every day out on the job. Like I said, you basically learn the symbols, you learn site plan, mechanical plan, electrical plan, structural plans. All this kind of stuff is what you'll go through, and you'll know where to find that material and how it regards to the sheet metal industry. The introduction to air handling. With the introduction to air handling, what you'll learn with this section is basically you'll learn the different types of air movement you have in the building: return air, supply air, makeup air, fresh air, anything like that. You'll learn some different types of exhausting type of air things you use, like chimneys, venting, anything like that. Just very basic things in the building. Okay. The metallurgy and welding. A couple things that I want to mention with that is that we use various types of metal in our trade. As you can see in this picture here, we have the perforated metal, we have the copper, we have the satin coat, we have the mild steel, we have the galvanized. Any of that kind of stuff we use in the trade. You'll see where we use it and why we use it, okay? And you'll do some very basic projects with some of these. With the welding, you'll actually get to do a little bit of welding. It'll be more of an introduction. And what you'll actually probably do more than anything is the GMAW, gas metal arc welding. And with this gas metal arc welding, basically, you'll just do very simple fittings that we do in the trade. And you'll actually get to do some of the welding with it. You'll do a little bit of soldering that goes along with that for drip pans, things like that nature. That'll pretty much cover that course. Okay. The math and applied mathematics. The first thing when you're actually doing your math, what you'll usually do is you'll do like ratios, area, volume, perimeter, and then you'll just basically we'll show you how to apply those in our trade, because we do a lot of stretch outs, we do a lot of like cord lengths, we'll do pattern angles, that kind of stuff. So we'll get to use all that and see where you apply it in the trade. Communications, like any trade, is very important because you're always communicating back and forth with either the general contractors, the shop itself, because we have a lot of shop drawings where we draw things and communicate with the shop to make sure that they actually make the equipment to what we want. Like any trade, you'll get into that. Resumes, things like that. Okay. What you're actually going to get out of this trade. Okay, so it starts your career in the growing trade. That is right now, this is one of the, I think most trades in general are really, if you get into the trade, you're going to have a great opportunity. You're going to have a hands-on approach to learning. So you're going to actually get to do most of the things that you'd see out in the job that you do as a first or second year apprentice. You'll work at a pace that works for you, meaning that we're versatile. We'll try to work with you. We'll build a solid foundation to start your apprenticeship in the sheet metal industry. And what I mean by that is, it's a 4-year apprenticeship to get your trade in this. And this is basically a 1-year program that you're going to be doing. And with that 1-year program, you'll get credited for 900 hours. There'll be a first and a second semester that you'll do at school. And then there'll be a work experience that you have to do for 5 weeks. And chances are that'll get you started with the trade. All my students that just did this right now are going out to work. They start on Monday. And as long as they show up and do the work, chances are they're going to have a job. Okay. What else can I say about it? That's about it. Sorry guys, I kind of ramble, I'm kind of hyper and excited. It's hard for me to stay still, so.
That was great, Willie.
Was it? Okay, I feel too hyper right now. I was kind of rambling a little there.
Yeah.
I'm not calm like
Are you able
people there. That's not my nature.
to? Are you able to make me presenter again if you go to
Yeah, okay.
just click my name and a little arrow should show up there, and
Okay.
if you can't, that's.
I'm sorry here. Where do I do that now?
Oh wait, maybe I can do it to myself.
Because I don't have that on my screen. It come up before for me to change it, but.
Oh yeah, I'm good now. Yeah, there we go. So Willie, I just that was a great overview. I'll just skip to, you covered those courses. The admission requirements for this program is high school again, and we'll teach you the math and things that you need to know. There is a program page for that. If I click that, here we go, sheet metal systems. So all of it's a certificate program. So this is a one-year program like Kimball's program. It's a one-year certificate. Brett's program is a two-year diploma. So that's the big difference at NSCC. 1 year you get a certificate, 2 years you get a diploma. But for sheet metal systems and for precision machining, that's sort of your first step towards certification in the trade. Then, you know, the next step would be to register with the apprenticeship agency, start apprenticing with somebody, or and work towards getting your own certification. And then I guess, you know, a lot of people, once they get their ticket, Willie and Kimball, is sometimes they'll start their own business or just sort of work wherever they want, I guess, after that point.
Yeah, an entrepreneur is definitely something that can happen for you for sure.
Yeah.
Especially if you start young.
Willie, with your program, is it most like people typically start out in residential type of work, like with all of the apartments that are being built in Halifax and things like that?
It just varies, okay? So there is a residential and a commercial side, but to say that most people start either residential or commercial, it just depends on what company you're working for. Some companies focus on the residential and some companies focus on the commercial, okay?
Right.
If you were to get into a larger company, then chances are you're going to focus more on the commercial, okay? Just depends on the company you work for.
Right. And Kimball, for you, around Pictou area, what are some of the industries or businesses that we've partnered with for work experience? And do some students have to go further than in the area? You mentioned you can't graduate enough, so.
No. This year we had a couple of them going to McGregor Industries, which is a large machine shop, fabrication shop. We had NC Machining, which is out of Linesbrook, which is CNC and machining. We had one fellow going down to the new, I'm trying to think, New Spokes, something like that, the company downtown in Glasgow, where they're actually rebuilding Toyota Land Cruisers. It's a couple $100,000 to $300,000 per unit, so they're ordered by rich people, and they rebuild them right from, all they need is one piece of them, and they can call them an original. And they do the whole thing over. There's a guy working there. We also have Hobbles Machining, that's got one fellow there. Right now, what has happened with the COVID, especially in the aircraft industry, all of the aircrafts, of course, were grounded for a while, and therefore Pratt & Whitney Canada, which builds aircraft engines, is probably a 40% world supplier, so the largest supplier in the world. They closed down basically to a skeleton crew, and most of the people that were there took packages and retired. So now they need to ramp back up to get the production going again, and they are desperate to get people into this trade, so that they're a really good paying company. So although none of my guys have actually gone outside the county, in Nova Scotia alone, there's a lot of work, because everything is starting to ramp back up, and of course then we got to produce things, and it's probably the same with, you know, especially with the, you know, what everybody else here is doing, electronics and the sheet metal work. I mean, when things start ramping back up, which is happening now, it has to happen because we've been down so long. It's these trades that are in dire straits for people. So I think in any of the trades, people are going to start seeing more job opportunities.
I'm getting calls all the time that they're looking for people and they just can't find them.
Yeah, same. We've had Pratt & Whitney trying to get us to modify programs to suit them, that type of thing. Like it's just, but there's just not enough students applying right now. When COVID hit, our application numbers dropped. They didn't want to come to the schools. So that's what happened to us. We dropped down to, from normally getting in the teens, down to, I think we had 5 applicants. And last year they reopened it. We still only had 10 applicants, and a couple of them ended up not being able to go through. So anyway,
Yeah.
we could use a lot more people. And there's a
Yeah,
lot.
so just like the other programs, there's a link there if you want to go to that explorecareers.novascotia.ca website. If you search sheet metal workers, you get some labor market information, but I would take it from the experts. There's lots of demand there. You know, like you say, we're not, we need to graduate more students, so to keep up with the demand. And Brett, I was going to ask you, at King's Tech, we're handy to Greenwood Air Force Base. So do some of our students ever find themselves working for defense or anything like that?
Not that I know of. I guess there probably would be a few electronic jobs. One of the guys I worked with at Michelin used to work at Greenwood, so way back in the day for sure, with the electronics technician program. But none of the current students we have work there. Okay.
And I know with, if you go to that career and future study tab on your program page, there is a line there that you can, I think, bring this program into some sort of weapons technician or something. There's something you can do in armed forces with, I mean, obviously there's a lot of electronics in the armed forces, let's put it that way. So if that's a career path for you, you can explore that as well. So we're getting to a couple minutes before 11. I've been answering some questions in the chat here and then kind of throwing a couple to you guys at the same time. So I think we're about ready to wrap this up. I just want to remind everybody that if you do have questions about anything you've heard in this session, you can email me at recruitment@nscc.ca. I've got myself and my colleagues are answering emails all the time, and sometimes we're sending them off to different people, student advisors, faculty. So happy to do that. And just keep an eye on our webinar page. We've got more program spotlights coming up. We're going to do some campus spotlights where we talk about particular campuses and what it's like there and the communities that they're in. So sign up for those. This one is recorded. I had a question from somebody wondering if they could request the recording for somebody in their family. So certainly email recruitment, we can do that. And we're also on social media, Facebook, Twitter, Instagram, all of those things if you want to stay up to date with what's happening around the college. So I do believe seats are available in all 3 of these programs. So if you've got your high school, and then in the case of Brett's program, you've got academic grade 12 math, you can apply online. International students, we ask you try to complete your application by May 1st. And then everybody, domestic students, you can apply. We'll keep putting people in the program right up until 2 weeks after the start of classes. So so apply if you have questions. Once you're admitted, there's financial support and bursaries and things you can apply for. They're all great programs with lots of career opportunities. So thank you, Brett. Thank you, Willie. Thank you, Kimball, for some insight on your programs. And hopefully we'll send some students your way.
Yeah, thanks for having me.
Thank you.
Yeah, good luck. Take her easy.
Okay, thank you, everybody. Have a great day.
Thank you.